So I've written over here on the board, or put up the sheet that we had before that has the properties of addition and multiplication with positive and negative numbers. Commutative property has to do with order. The associative property has to do with changing the grouping in expressions, and the distributive property is a property that involves both multiplication and addition. We want to use these properties to simplify some algebraic expressions. So let's look at our first example. We want to simplify 6 times the quantity 3x. Now, you might think to yourself, well, the answer to this is going to be negative 18x, and you're correct. You do multiply the 6 and the 3 to get 18, and then the answer is negative 18x. The reason why that's true is because of the associative property for multiplication. I'm going to change the grouping so that I multiply negative 6 and 3, and then what I get times x. Now, negative 6 times 3 is negative 18 times x. So the reason why negative 6 times 3x is negative 18x is because of the associative property for multiplication. Here's our next example. Let's simplify 2 plus the quantity 3 plus x. This time I'm going to apply the associative property for addition to combine the 2 and the 3. So I have 2 plus 3 plus x. So I've changed the grouping from 3 and x to 2 and 3. Now I'll add 2 and 3, I'll get 5 plus x. So I've simplified this expression now using the associative property for addition rather than the one for multiplication. So as you go through and you work these problems, what you're going to say to yourself is negative 6 times 3x is negative 18x. You won't always show this step after a while. But what you should know is that the step is there, and it's because of the associative property that negative 6 times 3x is negative 18x. Here's some more examples. Let's multiply 2 times the quantity 6x minus 3y. This is subtraction in here, and I'm going to use the distributive property to distribute this 2 over this difference. So I'm going to multiply 2 times 6x, and from that I'm going to subtract, there's my subtraction sign, 2 times 3y. So 2 times 3y. So I've applied the distributive property there to distribute the 2 over this difference, 6x minus 3y. So I multiply 2 times this and 2 times this. Now when we state the distributive property, we only state it in terms of addition, but it works for subtraction as well because subtraction is addition of the opposite. So since we've defined subtraction in terms of addition, the distributive property works for subtraction as well. Now, when I multiply 2 times 6x, I would apply the associative property for multiplication to multiply the 2 and the 6. The result will simply be 12x. Minus, there's my subtraction sign, 2 times 3y will be 6y. So there is an application of the distributive property where I distribute the 2 over this difference. This expression, 12x minus 6y, is exactly the same as this expression algebraically. Let's look at our next one. 5 times the quantity 7 minus 4y. Again, with the distributive property, I multiply 5 times 7, and then 5 times 4y. 5 times 7 is 35, minus 5 times 4y is 20y. So there's the simplified version of this expression, or the expression that I get when I apply the distributive property. Now notice that 5 times 4y is 20y. I don't distribute multiplication over multiplication. That is, I'm not multiplying 5 times 4 and 5 times y. I use the distributive property when inside the parentheses I have addition or subtraction. Here's our next example. This one involves exponents, and we're going to simply use our definition for exponents to expand each expression. This will be 4x times 4x times 9xy times 9xy. That's what these exponents 2 mean, is to write this down as a factor twice and this as a factor twice. Now, with the commutative and associative properties of multiplication, I'm going to change the order and the grouping of these numbers in this product and write this as 4 times 4 times 9 times 9 times x times x times x times x. There's all 4 of the x's times y times y. So that is simply an application of the commutative and associative properties for multiplication. I've grouped all the numbers together here, and then all the x's over here and the y's over here. Now I'll continue to simplify. 4 times 4 is 16 times 9 times 9. So I'll end up there, if I do that multiplication, with, let's see, 16 times 81. I'll have to do this real quick. 1296. 1296, when I multiply all this out, x times x times x times x is x to the fourth, and then y times, or just y times y is going to be y to the second. So when I simplify this expression, I end up with 1296 x to the fourth y to the second power. That's the equivalent of this expression right here, and I've done it by using my definition for exponents to just write these factors down twice. Then I regroup, I change the order and the grouping using the commutative and associative properties, so I have the number part, the x's, and then the y's. And then I just write it in a nice simplified form like that. Next, we want to combine similar terms, but before we do, I want to go over and show you a definition I've written for similar terms. Similar terms are two or more terms with the same variable parts. So, for instance, 3x and negative 7x are similar terms because the variable parts are the same, as are 4a and 5a. Now, we can combine similar terms by using the distributive property in kind of a backwards way. We add 4a and 5a by rewriting it as 4 plus 5, that quantity, times a. So in a way, we factor that a outside. So I have a times the quantity 4 plus 5, then 4 plus 5 we know is 9, and that's why 4a plus 5a turns out to be 9a, because of the distributive property. The only kind of terms that we can combine are similar terms because I have to have the same variable part in both places in order to apply the distributive property in this direction here. So let's go to the board now and look at a couple of examples. We want to combine 3x and 5x. Okay, using the distributive property in the reverse direction from the way we've applied it before, we write this as 3 plus 5 in parentheses times x. Now notice that I can simply multiply this out. X times 5 and x times 3 will be 3x plus 5x. So I know that I haven't made a mistake, and this is an application of the distributive property. But 3 plus 5 is 8, and that's why I can write this as just 8 times x. So 3x plus 5x is 8x. How about 6y minus y? Let me take away this set of parentheses right here. 6y minus y is equal to, in parentheses, 6 minus 1 times y, because the number of y's I have right here is 1y. And remember, I have to write this so that if I apply the distributive property back the other way, I get what I started with. Y times 1 is 1y, y times 6 is 6y. So I know that I've done this step correctly. Now, 6 minus 1 is 5y. So isn't that true that 6y subtract y would come out to be 5y? So I'm subtracting these numbers in front, which we call coefficients. 6y minus 1y is going to be 5y. Now, you may skip this step right here as you get better at these problems, but you need to know that the reason why 3x plus 5x is 8x is because of the distributive property. The distributive property is the thing that allows us to combine similar terms, and the only kind of terms that we can combine are similar terms.